There's a similar concept in ATM networks called CAC, Connection Admission Control.
Okay, so InServ is very stateful, very focused on individual flows and strict guarantees using RSVP and admission control. But then there's the other model you mentioned, DiffServ differentiated services. How is that different?
DiffServ takes a completely different philosophical approach, really. It was designed partly to address the scalability concerns of InServ. InServ requires every router to track every single reserved flow, which can be a lot of overhead in a large network.
Right, sound complex.
DiffServ simplifies things. Instead of managing individual flows, it groups traffic into a smaller number of classes. All traffic in the same class gets the same forwarding treatment.
So less granularity, more about broad categories, like having an express lane, a regular lane, and a truck lane, instead of reserved spots for every car.
That's a perfect analogy. And two key things change with DiffServ. First, most of the complex work classifying packets and marking them with their class is pushed to the edges of the network. The routers in the core network just look at the marking, called a DSCP value, and apply the corresponding forwarding behavior. They don't need to remember individual flows.
Simpler for the core routers.
Much simpler, much more scalable. Second, it shifts from per-flow guarantees to per-class differentiation. You get better service in a higher class, but it's not usually a hard quantifiable guarantee like with InServ RSVP. It's about relative priority.
Okay, so InServ is reservation heavy per flow, complex but strong guarantees. DiffServ is class-based, simpler core, scalable relative priorities.
You've nailed the core differences.
So just to quickly recap these tools, we have ways to sort of tag the traffic first.
Right, classification and marking, telling the network what kind of traffic it is.
Then ways to handle the queues when things get busy.
Congestion management, like priority queuing, FIFO, WFQ, deciding who goes next when there's a line.
And then ways to stop the lines getting too long in the first place.
Congestion avoidance, techniques that try to prevent severe congestion by, say, dropping less important packets early or signaling back to senders to slow down.
Got it. Classification, management, avoidance. Now, how does all this amazing QoS stuff connect back to the really fundamental internet building blocks, like IP addresses IPv4, IPv6, and the transport layer, TCP and UDP? Our sources mentioned those two.
Yeah, that's a crucial connection. IP addressing is, well, fundamental. It's how packets know where to go in the first place. QoS mechanisms rely on IP addresses to identify the endpoints of a communication.
The address on the envelope.
Exactly. And